Okay, so in our previous video, we had created a classifier here, and we learned about the how to we fit the classifier and how we use the classifier to predict the if a sentence was a positive sentence or a negative sentence. And what we want to do now is to evaluate the classifier. We want to see, okay, is this a good classifier? Is this a bad classifier? How do we do this? So generally, the way this normally is done, and it is something that we are gonna speak about in the next class, is the way this is done normally is instead of using the entire data set to train our classifier, instead of giving the entire data set that we have of all sentences and all the labels to our algorithm, we take some amount of this data and we keep it for ourselves. So here, instead of giving, so here we had like 10,000 sentences. And then instead of using all of these 10,000 sentences, we would use maybe only 9,000 of them. And then the rest, those 1,000 that were left, we keep for ourselves, and we don't give to the classifier. We don't show it. And then since we still know what are the correct labels for those 1,000 because we removed out them from here, then we can use those to evaluate, like to see if the value that is output by this predict function is the same that we were expecting it to output. So now in this case here, in this video, instead of doing that, what I'm gonna do is I created a toy data set here, and I'm gonna show you what would be the procedure, what we would do with those data that we kept for ourselves. And so here I'm doing this with a smaller example because I think that it's going to be a little clearer if I do this very concretely. So here I have like 4 sentences that are supposed to be negative. I mean, that are intuitively negative. So, whoa, this was very bad, horrible, terrible. I did not like the movie. The movie was horrible and should not be ever watched again, etc., etc. And then here I have 4 good sentences, like, whoa, this was awesome. This was an awesome movie. This was a great movie, blah, blah, blah. And then I created a list of these sentences, and then which I'm calling test sentences, and also I created a list containing the labels. So the first 4 of them, corresponding to these 4 here, are -1, and the other 4 are 1. So these are positive sentences. And then, okay, we need to do that same story. So we need to say processed sense equals, we will create a list comprehension where we say bag of words, S, and then I need to take this part here. So we call the bag of words function in each one of the sentences for S in test sentences. And then this will produce a list that contains that, like, where the first element is a bag of words for this sentence, the second element is a bag of words for this sentence, the third element is a bag of words for this sentence, etc., etc. Okay, so now what do we do with this? So I mean, of course, we use the classifier that we trained in the previous video, and we give to it this bag of words, like this list here. So the list of bag of words, and then we see what the classifier will output. So what happens is now it produced 8 elements, and these 8 elements here are each, like the first one here corresponds to the first sentence here, the second one corresponds to the second sentence, the third one corresponds to the fourth sentence, the fourth one corresponds to the third one corresponds to the third sentence, fourth one corresponds to the fourth sentence, and so on. So as you can see, this list here that it produced is what the classifier predicted, right? What the classifier thinks is the correct output. And I'm gonna put this into, say, predicted, like into a variable called predicted. And I'm gonna call this test, instead of test labels, maybe I should call them, like, maybe I should call these expected. And like, because the type of this element here is an NP array, I'm also going to say to create an NP array, just so that both of them are comparable or of the same type. So now something that I can do is to say predicted equals expected. And you see it creates a list here that like it is true here because the thing that was, so let me just show you again what was predicted. So the thing that was predicted by the classifier was the same as what was expected. Oh, here, what was expected. So that's why it returned true. Now this one was the same also, so that's why this is true. So this one here is false, the fourth one is false, because the expected was a -1, but it predicted a 1 here. So now we see, okay, we have like 6 trues here out of 8 elements. So now there are several measures that we can use to evaluate an algorithm, like a classification algorithm. The one that we are going to learn here is what is called precision. And so how does it work? So we know with this expression that out of the 8 elements that we compared here, like where the expected was compared with the predicted, only 6 were correct, were the same, right? These that have true here. This is true here because we are using this operator here. So predicted equals expected, and then it compares each one of the elements separately. So that's why like some of them are true, some of them are false. So it is true when predicted equals expected, like when this element equals this element. But so, okay, so I'm gonna create a variable here called comparison, where I compare, where I store the output of this thing into a variable here. So comparison here is, so I'm gonna run this, and this comparison is the same thing here. So if I say comparison where comparison equals true, then I will get only the lines where comparison equals true in comparison, which is the same as saying I only want the elements here that are true, and this will give me only trues here. Then if I get the length of this, then I will get 6. So 6 elements is the number of trues here. And the actual length of comparison is 8. So precision is exactly this. So it's calculated exactly in this way. So precision is the number of cases when you got it right out of the total number of test cases. Okay, so when I recorded this video, I actually didn't realize that I said and I explained the wrong measure. So I said that what we are calculating here is precision, but what we are calculating here is actually called accuracy. So precision is another measure, and we're gonna see this in the next week or maybe in the other week, but this is not what precision actually is. What you need to know is that this measure is called accuracy. And this is a very, very, very useful and used measure of how good a classifier is, how good any model is. So this is something that is very important for you to learn. So that is it for this week. I hope that this was not too intense, and I hope that and if you have any questions, you can always make them in the forum or ask them in on Wednesday. It's your choice.